In examples 5 and 6, we want to take this process for solving systems of equations and apply it to some applied problems. In example 5, Mitchell currently sells stoves for company A with a given salary and a particular commission per sale. And now another company is offering him a similar position with a higher salary but a lower commission. We want to determine how many stoves he would need to sell for these options to equal. So where would he make the same amount of money in either position? To do that, we want to identify the information that we're going to put together for a single equation. In this case, we can take the information for company A, where he makes that salary of $12,000 plus a commission of $150 for each sale. Translating that into an equation, we would get y equals 12,000 as a fixed value plus a variable value of 150 times x. So $150 per stove that he sells. The second job now is offering this alternate salary and alternate commission, and we could translate that into the equation y equals 24,000 plus 50x. Now we want to find the point, the xy pair that is the solution to this system, because that's going to tell us how many stoves he would need to sell and then how much money he would be making at those two jobs. Flipping back over to Desmos, we can graph these two lines. And as we mentioned, sometimes that point of intersection isn't immediately obvious to us. If we look back at the problem, though, we're given a hint. And in this case, that's that we want to set our viewing window for x to be -10 to 200 and y to be -10 to 35,000. In Desmos, if we click on the wrench icon, then we can change these values for our minimum and maximum x and y values. So we'll click there and change this to -10. For some reason, it's not letting me type a negative sign. I don't know if that's because I'm on a mobile device. I haven't run into that on a computer before. So I'm going to pull up the touch keyboard here and put in that minus sign. And then I can just type in my other bound here of 200. Then for y, we want that minimum to be -10. And that maximum to be 35,000. What we've done is adjust the x and y values, our x and y axis, for viewing these graphs. And now we can see that point of intersection occurring at 120, 30,000. Meaning our solution occurs at 120, 30,000. Translating that into the context of the problem, what that tells us is that if he sells 120 stoves, he would earn that same amount, that $30,000, at either job. If this was you in a real-world scenario where you were considering two different positions, then you could look at how many sales you make in a given month to determine which of those positions is going to actually make you more money, earn you a higher salary each year. In example 6, Andrea and Bart go to the farmer's market to purchase some fruit. Andrea buys 4 apples and 5 oranges with a cost of $3.10. Bart buys 4 apples and 6 oranges with a cost of $3.40. We want to use that information to figure out the cost of an orange and the cost of an apple. And again, we're given a hint to set our viewing window for x and y to both be -2 to 2. We'll look at what each individual person purchased to set up our two equations. In this case, we know that Andrea buys 4 apples. So that's 4 apples times some amount of money per item, plus 5 times y, where y is that price per item. And then that total spent is 3.1 or $3.10. We're told that Bart buys 4 apples, so 4 apples at some price X plus 6 oranges at some price Y is going to be a total cost of $3.40 or 3.4. Flipping back over, we can type in those 2 equations. And since we adjusted our viewing window for the last problem, we're not seeing anything remotely like what we want to see. So we'll change that minimum x value to -2, maximum x value to +2, and then do the same for our y values, which has again shifted the domain and range that we're viewing our graph on, and we can find that point of intersection at 0.4, 0.3. Translating that into the context of the problem, it's telling us that apples, because we used apples as our x value here, apples cost 40 cents a piece, and oranges cost 30 cents a piece.